Hello, welcome to Ekidel, where we train future civil and structural engineer. Today, I'll be showing you how to model a Raft Foundation using Protastructure. So by the end of this lesson, you will be able to perform a full modeling and design of a Raft Foundation for any concrete building using Protastructure software. So right now, I'll say you should sit back and then while you learn how to design a Raft Foundation using Protastructure software. Okay, so let's begin right now. Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Moka and I am your instructor. Today, I'll be showing you how to design a raft foundation using Protastructure. As you can see that this is just a one-story building having a cantilever around, and we have already done performing the superstructure design, and now we want to enter the substructure, and the choice of our foundation for this building is Raft Foundation. So by the end of this lesson, you will be able to perform a full design of a Raft Foundation using Protastructure software. Okay, so to now begin the design of Raft Foundation, you have to go out from this 3D view interface and go to plan view. And when you go to plan view, you have to come to story 00, because story 00 simply means our foundation level. Okay, so right now on this story 00, which is the story 0, you will only see your column, as you can see it right now. So right now the type of raft foundation that we want to use is raft on beam. So right now I'm going to insert my raft beam, which simply means also ground beam. So I'll quickly click on this place right now, which is the beam icon, or I go here, concrete member, and then click on beam, and a dialog box will appear for the beam property. So I want to use my beam, my width of beam to be 225, and I want to use my depth of beam, which is the height or the depth of beam, to be 1200, because this place is very waterlogged, and the bearing capacity of this soil is 65 kilonewton per meter square. So right now, once you're done choosing your width of your beam and your depth of your raft beam or your ground beam, then right now you now have to now just make sure that this place is not selected, it's just empty, and then you have to now click on this place and begin to insert your beams. So you begin to insert your ground beam column by column to column. So I'll begin to do that just now. I'll do just that here, and then continue again to do this here and do this here. You have to insert your beam column to columns. So I'll come again here and then insert from here to here, and then do the same thing here. Okay, now it may be you don't know how to design superstructure. I'll see that you can check most of our videos. We have done a lot of videos on superstructure and also other type of part foundation. So you can check on most of our videos here on our channels, and then you will be able to perform a full structural design for a concrete building or for a steel building using Protastructure software. Okay, and then I'll just do that right now, and then do the same thing here, just to tie all the columns together using the ground beam. That's what I'm doing right now. So that's just the principle. So I'll do the same thing here, tie from this to this, and then go from here to here, and then go from here to here. When I do that, I'll press escape key to choose the next point. So I'll do the same thing. I'll go all the way down here to this place, and I go all the way down here to this place, and I'll press escape key and then take my beam from here to here and press escape key. I'll go all the way from here now to this place, and then go all the way down from here to here, and then all the way down to here, and I'll go again by joining this here to form a panel, because there will be a slab after we have done with this beam insertion. And I'll insert this also here, and then go here and insert this here, and then go again and insert this here, and I'll go and close up this panel here. Okay, and then I'll go again and do the same thing here, insert this and insert this. So you can now see that how we have inserted this ground beam. Now, for you to make your choice of foundation to be a raft foundation, that should be if only the bearing capacity of the soil where the building you're designing is to be inserted is very bad. So if the bearing capacity of the building is bad, that is only when you can make your choice of foundation to be a raft foundation. Else, I'll say that you should go and use a pad foundation. And also another type of foundation again that you can use before you cannot make your choice of to use a raft foundation is a wide strip foundation, where you have a footing and also a ground beam. Okay, let me just finish up right now for that, and I'll insert here, okay, no one here. Finish up this first, and then if maybe you're having any confusion on how to insert your ground beam, you can still go back to your first floor like story 1 to go and check how your beam are being arranged on that area. So I'll do the same thing here and then cover up here, okay, and then cover up here. Okay, now I'll just go and close up this place here. Here becomes a panel. Okay, that's nice. Now it's your beam arrangement, your ground beam arrangement on this place determines it lies on your hands, which is who is a structural engineer. So you have to now determine how you want to make your ground beam to run to like the direction of your ground beam. So okay, let me go and check how I did my beam insertion in this area. So I'll just go right now and click on story 01 here and select story 01 and navigate to story 01, and then let me check it out just now how it looks like on story 0. Okay, this is how it looks like where beam runs all the way down. Okay, so I go back right now to go and do the same thing there, and I'll go here, click on my beam here, right when the dialog box appears, check this. Okay, it's still the same setting properties, and I'll choose here and put here right now, and then I think something goes this way, it goes again this other way around here. Okay, this is how this place looks like. Okay, then how does this place looks like? Let me check it again on the story 1. Okay, it comes up just in a seconds. Okay, now it goes all the way down and close up here. Okay, and then that's how it looks like. I go back to this place right now. So if maybe you're having an issue like confusion, you can just look at what you have, how your beam runs on your story 1, and then just follow it up. I'll go again and check again how I did here, if this how this place looks like, and if it's the same thing, I'll just leave it the same way it is. Okay, I can choose to ignore this beam here for on the story 1. So right now I'll just check around again, everything looks okay, and I'll go to story 1 again and check. Let me check story 1. Let me close up this place. I don't like the way here is, but leave it there. Here can still be a panel. Okay, I want to close up here. Here, this panel looks too big for me, so I'll just go and click on the beam and then close it up right now. Close it up right now. Okay, so once you're done inserting your beam, as you can see here right now, this is nice. Okay, once you're done inserting your beams right now, the next thing to do is to escape and then go and click on your slab. While on your slab right now, go and click on slab. Now on the slab right now, a dialog box appears. You have to choose your slab depth of slab. For this case, I'll choose 200 as my depth of slab, which is one of the most common depth of slab for our foundation. But most people use 400. I've done a slab foundation depth before of around 850, but that is without the beam, just normal slab, just on this slab. That is called a plate raft. So here now, right now, I'll choose type 1 and then choose my this, okay, and then go to my this place. On this place called relative level. You know what we are designing for is an inverted raft. So I'll go here right now and put my relative level. How do you get this level right now? This level is gotten by where you have to subtract your depth of beam, which is 1.2, minus the depth of slab, which is 200. So if we do that right now, we are going to get 1000. So I'll put in 1000 here, my value, and then click on this place to insert my slab, my first slab. And then I'll just go and close this up and then check on my 3D view to see what I have just done just now. So I'll go here all the way down to go to my 3D view. While on this view right now, I'll just go to this place first and then make my views to be vertical, where I can get the where I can see the plan view and also the 3D view. I'll close here right now, and then let's check the place where we just inserted our slab just now. Now you can see the first Raft slab that we have already inserted just now. I can see it here. Now the Raft slab comes up because we put relative level to be 1000, as you can see there. So you get this level by simply doing the depth of your beam minus the depth of the slab, your assumed depth of slab, which you have assumed, which is 200 in this case. So 1.2, which is the depth of the beam, minus 200, that gives me 1000 millimeter as my relative level. So with this right now, I'll just click on back to slab and begin to insert slab in every area of these panels. Okay, so I'll go and type this. I'll go and put the properties which I want. Again, come here and put the properties which I want, 200 of my depth and my relative level to be 1000 millimeter. I'll begin to click. While I'm clicking, you'll be seeing how these panels will be filling up with the slabs. I'll begin to click right now. Oh God, let me just come back again. Let me just go here and take this property of slab, which I've already done before, and then begin, and it will take automatically the properties of the slab, which is already there. I've already shown you how to input all these values, and make sure you put this place called relative level, else your slab will go downward and will be in contact of the soil directly. Now what happens, you can see that there is a space between the bottom of the beam and the slab. There's a depth of space of 1 meter. This space here will be filled with a sharp sand, and then we will now use a polythene material which will serve as a waterproofing membrane. Okay, so right now I begin to insert my slabs just now. I insert, you can see how the slab is being filled in right now. I begin to insert my slab in all my panels. Even where you have staircase, you have to cover it up with slab because this is foundation. Okay, it is only on the first floor and second floor and other superstructures that you can leave the staircase place void, but on the foundation you don't have to leave any place void because that is foundation. Okay, so right now you cannot see how we have just inserted all our slabs just now for the raft area. Now there is something I used to call toe, which takes care of overburden pressure, active pressure on the bottom of this beam. Now because of soil always like to fight back when a load is being superimposed on top of it. You know, when this building load right now rests on the soil tends to display, you understand, displaced. That is what they call displacement, initial displacement. Now over time the soil tends to come back to its normal shape, and at that point where the soil tends to come back to its normal shape right now, it's coming back, it will cause what they call overburden pressure or active pressure on the edges of this beam, on the beams here. And if this beam does not have a toe, then this beam will be affected. So in my own design, like I told you, here in Ekidel, we teach real life examples and not just for the sake of teaching or just for the sake of getting views. No, we teach a real life example. That's why Ekidel is a place where we train future civil and structural engineer. So always provide a toe on your raft beam if you're using a raft beam foundation. Raft on beam foundation, sorry. You always provide a toe which will take care of active pressure or what they call overburden pressure around your ground beams for the raft beams. So right now I'm going to provide a cantilever slab which will act like a toe, and then on the part 2 of this video I'll have to show you the structural detailing of how that works and how you can detail that area, because this software will not be able to detail that perfectly. Okay, so right now we will now go here, the same place here, slab, and click on slab. Now on this place right now, one of the developers appears. I will have to choose type
2F, because this type 2F is for cantilevers. Now I want my toe depth, I want my toe length, which is cantilever length, to be 500. That should be your minimum that you should use, 500. You can go as far as using 800 if it is failing. So if during our design and we are still having these beams are still failing at the edges, or the slabs around there are still failing, is still failing, then we will not have to go and increase our length of toe for this ground beam. This toe is simply the same toe that you know in when you're designing for what they call retaining wall. Okay, so right now I'll go again here and then remove this relative level, because I want the slab, this slab will be, this toe slab right now will be at the bottom of the beam and not at the top here. So make your relative level to be 0. So if I go ahead now and insert that, this is the end here. If I go ahead here right now and insert that here, and begin to insert it from here to here, and click outside, you will see it here. This is what they call toe. So you can see it there right now. This is what they call toe. So this toe here, this toe slab right now, which is the cantilever slab, takes care of the active pressure that is meant to affect this ground beam at the bottom when the soil tends to compress back to its normal shape after displacement that was caused by this weight of this structure. Okay, so right now you have to put your toe on all the areas which you have beam. So that's what I'm doing right now. I'll click on this, and click on this, and click on this column, and go over here and click again and click upward, and go click on this column, click on this place, go outward and click, and let me just minimize that. Let me just zoom in so I can zoom out so that you can be seeing everything. And I'll go again right now and click on this place, click here again and click. Okay, and then I'll go here again right now, click at this place, and click. Let me just click again, click here and click here and click. Okay, and I'll go here again right now, click here and click here and click. Now if you find this video very, very useful, I would say you should click on the subscribe button and also like this video, and also share this video to your friends so that they can also gain what we are doing right here on Ekidel. And also recommend our channel to your friends. If you're a student, recommend to your colleagues, and also if you're a worker also. And then if you have any question to ask, I would say you can drop your question on this comment section, and then we will also reply you in less than 1 hour. And if maybe you want to also have a private class, there is what we have introduced, which is Ekidel mentorship program, where we will have to train you thoroughly on structural design. We will have to train you thoroughly on structural design. So if maybe you want for us to train you especially on structural design, I would say that you can just email us, or just use our number and just send us a WhatsApp message, or you can drop a call, and then we can pick it up from there and then guide you on how to register for your special class on Ekidel mentorship program. Okay, so right now you can see what we are doing. We are inserting all our toes right now. Now this is not common in Protastructure or the videos that you have been seeing, because most people that teach, they don't teach practical. Like here on Ekidel, our dream is to train every future civil and structural engineer to be very, very good in structural design, because that was how we were trained. Okay, so right now you can now see that. Let me just turn off this on grid line so that you can see it perfectly. So this is how your Raft foundation should look like, so that when the load of this structure right now hits on this soil, let me just maximize this. When the load of this structure right now hits on the soil tends to displace out because of the load. The soil tends to displace, even the water tends to displace. But over time, the soil tends to contract back, like come back to its normal shape. Now, when the soil is coming back to its normal shape, it will affect the structure at the bottom, causing it to have an effect of active pressure. Now, if you don't provide this toe on this place, what happens is that the soil tends to pull this structure at the bottom, and what happens is that there will be an overturn of this beam. This beam will tend to overturn, but having this toe right now, this toe will tend to we now tends to withstand or resist that active pressure from hitting directly on this ground beam bottom. Okay, so right now you can now see that how we have used in less than 30 minutes to just model our Raft Foundation. As you can see it here right now, this is how to model a Raft Foundation in Protastructure. And in our next stage right now, we will now begin the structural design, which will now have to run the analysis and design of this Raft Foundation. So that will be on the part 2 of this video. So if you find this video very, very useful, I would say you should stick to it so that you can gain the whole lessons and stages of how to design this Raft Foundation. Okay, so thank you right now, and watch out for the full structural design for this Raft Foundation, because what we have just done right now is the modeling. So I would say that you can use the one that you have already modeled for and use it to practice for this Raft Foundation. Now listen very, very carefully. What makes you very, very good in software is when you have learned anything here on Ekidel, always try to practice what you have learned. Don't just watch the video and keep it. Once you practice it, there will be your brain will not have to retain that. The next time when you have to encounter that kind of issue, you will not it will not be a new thing to you. But if you just go ahead and just watch the video and just go without you practicing, then you will miss a lot, because your brain will not be able to retain all the steps that we have taken. Okay, and also I will say that if you find this video very, very useful, click on the subscribe button and share this video and like this video. Okay, now watch out for the part 2, which will upload anytime this week. Okay, so thank you so much, and God bless you for staying to this end. And if you have any question, don't forget to drop the question down below. And also, if you want to join our Ekidel mentorship program, I will say that you should check on the link down below and join, and click on the join button. Although it's not free, you have to pay some certain amount. But I tell you the truth, if you go through the syllable of what you're going to learn, then I'll tell you that in less than 1 year, you will be a guru and you will be a pro in structural design. Okay, so thank you so much, and God bless you. Bye.